Hi, welcome to the lesson on quadratic equations. As you know, it's one of the part of algebra. So before going to say about how to find the roots of a quadratic equation by using a formula, let's discuss what is quadratic equation. That's very important. Okay, so what is a quadratic equation? Can you remember it? What is quadratic equation? Yeah. So we will see what is quadratic equation. Here I mentioned ax square plus bx plus c is equal to 0 only if it can be put in the form of ax square plus bx plus c equal to 0, and where a is not equal to 0 is called a quadratic equation. The name comes from quadra, means quad, means square. As the variable is squared, in other form you can say as x square. As you know it, if you say ax plus b is equal to 0, it's a linear equation because the degree is 1. Ax square plus bx plus c equal to 0, here the degree of this equation is 2, hence we call it as a quadratic equation. If it is ax cube plus bx square plus cx plus d equal to 0, here the degree is 3, then we call it as a cubic equation. So the name of the equation we get by the degree of the equation. What is degree? As you know it, degree of the equation means simply the highest power of the variable, we call it as degree. Clear? So here I collected some of the quadratic equations which is in a different form. For example, x square equal to 3x minus 1, 2 of x square minus 2x equal to 5, x of x minus 1 equal to 3, 5 plus 1 by x minus 1 by x square equal to 0. So I collected, but in first first impression, so you may a little bit of confusion whether it is a quadratic equation or not. Then how to identify? That's very important. First you have to convert the equation in the form of standard form. As you know it, ax square plus bx plus c equal to 0. So convert in the form of ax square plus bx plus c. Then that seems to be as a quadratic equation. X square equal to 3x minus 1. So you can write it as x square minus 3x plus 1 equal to 0. Correct? If you compare with the standard form ax square plus bx plus c equal to 0, here a equal to 1, b equal to minus 3, c equal to 1. Now it is very clear. There is no second thought whether it is a quadratic equation or not. For example, 2 of x square minus 2x is equal to 5. Of course, here x square is there. Maybe you identify that it's a quadratic equation. First, you convert in terms of a standard form. 2 of x square, 2x square. 2 of minus 2x is minus 4x. When plus 5 brings this side minus 5, and 2x square minus 4x minus 5 equal to 0, as you know it. When you compare with the x square plus bx plus c equal to 0, then a equal to 2, b equal to minus 4, and c equal to minus 5. Okay, the first two, there is no confusion, but clearly the x square term is appearing there. So all the students may understand that it's a quadratic equation. But when you come into the third equation, that is x of x minus 1 equal to 3. So here there is no x square directly. Then how to identify? So we have to open the brackets. X of x, x square, x of minus 1, minus x, minus 3 equal to 0. X square minus x minus 3 equal to 0. Now, is it clear? So every children can say this is a quadratic equation. Let's take one more. 5 plus 1 by x minus 1 by x square equal to 0. So x square is appearing in the denominator. So if the variable appears in the polynomial, then that's not a polynomial. We can call it as an algebraic expression only. A lot of confusion may comes. But when you multiply the total equation with x square, the equation will be converted as 5x square plus x minus 1 equal to 0, where a equal to 5, b equal to 1, c equal to minus 1. So students, you have to first correct the quadratic equations. If they are not in the standard form, make it into standard form. Then you can say whether it is a quadratic equation or not. Is it clear? Okay. Now we will see, coming to our concept. Already you learned in the previous videos, you will learn the concept. What is a quadratic equation? What is the root of the quadratic equation? And how to find the roots of the quadratic equation by using various methods, making a complete square, or you can factorize that. So now I'm bringing you one formula, that is x equal to minus b plus or minus under root b square minus 4ac by 2a. The formula gives the solution of the quadratic equation. You can use this formula for any kind of quadratic equation. When there is a possibility to resolve into factors, then only we can use the method of resolving into factors. Okay, if there is a possibility to make a perfect square, then there is another method. Of course, if these two is not possible, then you can use a formula method. Not only for that, for all conditions in all cases, the formula can be used to get the roots of the quadratic equation. So when you observe this formula here, the solution to the quadratic equation are where it is equal to 0. So students, there is small confusion in the minds of the students. That is, root of an equation, 0 of the polynomial. That's a very important. Oftenly, the teachers and students also using root and 0 in the common usage, but generally we will use the root for an equation and 0 of the polynomial. That's there is a little bit of a confusion. But in Telugu medium, there is no difference, because simply we will call it as Bahupadi Sunyam for Bahupadalu and simply Moolam for a quadratic equation. There is no confusion. The word is completely different. But here, as a small, so we can say as root only. That's a very important. Okay. Here, one more concept to call it as plus and minus. We see this is plus or minus. When you come into this and plus or minus, it gives that there are two. When you take plus, you will get one value. When you take minus, you will get another value. Okay, the plus sign means there are two answers. It's a quadratic equation. A quadratic equation has two solutions. For that reason, here the plus or minus are used. Okay, we will see what are those things here. X equal to minus b plus or minus under root b square minus 4ac by 2a. When you take plus, this is the root. When you take minus, then x equal to minus b minus under root b square minus 4ac by 2a is the second one. So when you take plus, you will get one value. When you take minus, you will get another value. These two values will be considered as the roots of the quadratic equation. Here, b is a real number, a is a real number. There is no doubt at all also. But b square minus 4ac, which is under root, you can't say always it's a real number. So it's discriminate the nature. So for example, b square minus 4ac is positive. Then we'll get a real solution. When it is 0, b square minus 4ac is 0, we will get just 1, because when b square minus 4ac, if you see that b square minus 4ac is 0, then you have x is equal to minus b by 2a only. There is only one solution, one real solution. Is it clear? Okay. When it is negative, we get a pair of complex solutions. When it is b square minus 4ac, which is negative, the value under square root is negative. We call it as imaginary number. Okay, so a plus ib or bi is called a complex number. It is a general form of a complex number. So we can say, so the discriminant of the quadratic equation is negative, then the roots are complex numbers. When the discriminant is positive, when it is not equal to 0, then they are real solutions. When discriminant equal to 0, then it has only one solution, or simply the roots are equal. So b square minus 4ac is in the formula above. It is called discriminant because it can discriminate between the possible types of answers. So it discriminates the answer. For that reason, simply we call it as a discriminant. Okay, so maybe you understand that. So by using this formula, you can find the roots of the quadratic equation in a very simple manner. Okay, let's see. Using this quadratic formula, just put the values a, b, c and quadratic formula and we can do the calculations. So let's see one problem. 5x square plus 6x plus 1 equal to 0. Just compare with ax square plus bx plus c equal to 0. So a equal to 5 here, b equal to 6 here and c is equal to 1. This is very important. So first you have to observe this very carefully. First you have to write the coefficient, then write the quadratic formula, that is minus b plus or minus under root b square minus 4ac by 2a. Then substitute the values here. B is equal to how much? B is equal to 6. When b is equal to 6, minus 6 plus or minus under root 6 square minus 4. A is how much here? 5 and c is 1. So by 2a, 2 of 5. Then you simplify that. Minus 6 plus or minus 6 square is 36. 4 5 is 20 by 10. 36 minus 20 is 10. Of course 16 and minus 6 plus or minus root 16 by 10. Of course you know that root 16 is how much? 4. So x equal to minus 6 plus or minus 4 by 10, or you can say minus 6 plus 4 one value, minus 6 minus 4 another value. Of course 10 is the denominator for both. So minus 6 plus 4, that is minus 2 by 10, which is minus 0.2. And minus 6 minus 4 by 10, that is minus 10 by 10 minus 1. So we can just, if you observe that a screen, then the graph is already shown that. So one root of this quadratic equation is minus 0.2, another one is minus 1. Okay, we will check it whether it is a correct or not. So by substituting the values minus 0.2 and minus 0.2 here in the place of x, then 5 of minus 0.02 whole square minus plus 6 of minus 0.2 plus 1, which is 0. So and we will check another one, that is minus 1. 5 of minus 1 whole square plus 6 of minus 1 plus 1, that is 5 of 1 plus 6 of minus 1 plus 1, that is minus 5 minus 6 plus 1 equal to 0. Is it clear? Like you have to check the equation. That's a very important. So let's take one more, that is 5x square plus 2x plus 1 equal to 0. So a equal to 5, b equal to 2 and c is equal to 1. Here the b square minus 4ac, the discriminant is very clear, it is negative. So when it is a negative, the roots are, it's very clear, they are complex numbers. So here b square minus 4ac is when is minus 16, then it is 4i. So the roots are x is equal to minus 2 plus or minus 4i by 10, or minus 0.2 plus or minus 0.4i. Means minus 0.2 plus 4i minus 0.2 minus 4i. So when you observe the graph which is drawn based on these values, very clear, the graph does not touches the x-axis. Clear? So the graph does not cross the x-axis. That's why we ended up with a complex number. If it is touches, simply it has the root. How many points it meets the x-axis, that will be considered as the roots as you know it. So it doesn't touches the axis, means there is no real roots. Simply you can. Now let's take one more. X square minus 4x plus 6.25 equal to 0. Here I collected some good examples which are not given in the textbook with various difficulties. Then if you learn this, you can do all the problems from your textbook. Here b square minus 4ac, when you see that b square minus 4ac, it is minus 9. So here minus of minus 4 plus or minus root under minus 9 by 2. Here root minus 9. Of course it is 3i. So the roots are x equal to 2 plus or minus 1.5i. The graph does not cross the x-axis, means there is no real. That's why we ended up with a complex number. When you see this, but an upside down mirror image of our equation does cross the x-axis at 2 plus or minus 1.5. See, here this is a minus 2. Here what is the root? Here 2 plus or minus 1.5. So but the mirror image cross it. So like you can verify it. Now coming to the real world examples of quadratic equation. The question is, a ball is thrown straight up from 3 meters above the ground with a velocity of 14 meters per second. When does it hit the ground? So it's very clear, the height starts at 3. Then we will consider, and it travels upwards at 14 meters per second, that is 14t, and gravity pulls it down, changing its position by about 5 meters per second square minus 5t square. Then you will get an equation that is 3